Okay, so we have a kind of problem like this. We are trying to find the limit as x approaches to infinity of a rational function. Now, student may feel very difficult because of the infinity symbol, but I'm gonna convince you and try to help you understand how easy it actually is. But to make it look easy and to actually understand how easy it is, you will need to use a little bit of imagination. So I hope you can follow me closely and understand this. So what we can do here is let's go ahead and write this expression bigger, because we are going to do some cosmetic changes of this function. Now again, this is conceptual way of doing this. It's not going to be something you show on paper, but if you have a multiple choice question, it's going to be a lot easier for you to handle. Okay, it's going to take you way less time as long as you understand the concept. So the concept here is this. Now just imagine that x is going to be substituted with infinity. Okay, now going to be, so it's not there yet, but it's going to happen. So just think about this. If you have 3 times infinity squared plus 1, just focus on this part of the numerator. Does the plus 1 really matter? I mean, think about this. 3 times infinity squared is going to be a huge number. And you add 1 in there, does it really matter to the magnitude of the number? I mean, I know it's different, but you know, it's not really that great of a difference. So in that case, we can sort of ignore the plus 1 because we know it's a big number. Okay, so that's the conceptual thinking. And we move on, okay, right here. Okay, negative x plus 2. Think about this, negative infinity plus 2. I mean, plus 2 on top onto the negative infinity. Is it going to change a whole lot? Not really. So we're going to erase this as well. Okay, so now we are simplifying the function. And then you think about, okay, let's look at these two. Well, you have infinity to the 4th power. That's a huge, huge number. And compare this huge number with 3x squared, which will be 3 times infinity squared. I mean, this is going to be way bigger, way bigger. So this one, not really a major factor of affecting the magnitude of this whole fraction. And we carry the same logic over here, x cubed. It's a huge number, minus x, I mean infinity cubed minus infinity, still going to be infinity, like way bigger than infinity. So that one doesn't matter. All right, now, so if we look at this, let's say we simplify this equation, I mean this expression, not equation, and then we have this. And guess what? We have some simplification. Okay, so we have only this, and as a result, our limit is simply infinity. Now, this is the kind of problem where you would see for solving for the horizontal asymptote, and it's very similar. So what does it mean, okay, if it is applied into the horizontal asymptote case? If this is the function, you want to find out the asymptote. Well, first, do you understand what it means when we have why do we use limit as x approaches to infinity as the way to find out the horizontal asymptote? Well, let me give you a quick example. Let's say we have a horizontal asymptote at 1. Okay, I hope that you understand that we probably would draw a graph to resemble something like this, and maybe like this. So what it's saying is as x is getting bigger on this function, bigger and bigger and bigger, we can extend this graph infinitely. The function is going to get closer and closer and closer to what value? 1. So in this case, we will say, oh, the horizontal asymptote is equal to 1, or in other words, the limit as x approaches to infinity of this fictitious function, it's going to be 1. Now, what about this? If this is actually the function, and our limit is infinity, well, then we will say, well, do we have a horizontal asymptote? So pay attention to this. We sort of have a horizontal asymptote. It's like way up there. Where is it? Infinity. Can you see it in a normal graph paper? Not really. So if we say, well, if a function, okay, let's say g of x here, the limit as x approaches to infinity of g of x is equal to infinity, then our interpretation is that horizontal asymptote does not exist. Okay. Now the limit exists; it's infinity. It's just the horizontal asymptote does not exist. So it's a little bit of extension from this limit problem. Now again, this is a conceptual approach. Okay, it helps you to do this problem without much of the writing. You can just think about it. You can just do a comparison, and then you can get to the answer. And by the way, if you remember in your previous math course, based like a pre-cal something, algebra 2. Do you remember that when you learn how to find horizontal asymptote, your textbook will tell you that if the numerator's power is greater than the denominator's power, the leading power, then there's no horizontal asymptote? Do you know why that's the case? It's because of this conceptual approach. Okay, the power in the numerator is greater than the power in the denominator. So guess what? The limit, it's in infinity. We can't see it, so we say horizontal asymptote does not exist. Okay. Now let's go ahead and do the paper method, like when we have to actually show our work. So if we have to show our work, okay, what do? Hold on. Okay, so let me rewrite this function once again. And what we will do is to do something the same for numerator and denominator, which is we are going to divide both the denominator and numerator by x to the third power. Okay, and right here. And then you question, why is it x to the third? Why not x to the fourth power or any other power? Well, the problem that we are trying to solve here is that we do not want anything that's 0 or undefined in the denominator. And so to solve that problem, well, we just look at the greatest power of the denominator and do it, okay, and divide it for both numerator and denominator. And right here, we're just doing simple simplification. Okay, and just do this. And then the next thing that we do is to do substitution. So we go ahead and substitute all the x's with infinity sign, and then we can compute. Well, infinity is just infinity. Let's just leave it there for the moment. 3 over infinity squared, it's 3 over a huge number. So that becomes 0. That becomes 0 as well. 1 is there, keep it. 1 over infinity squared, 0. 1 over infinity cubed, 0. So what's left? Infinity over 1, which is basically infinity. So either way, you have the same answer. This is much faster, and it's really about your conceptual understanding of what it's the meaning of a limit as x approaches to infinity for a particular function, and how you can tie this understanding with horizontal asymptote. Okay, so that's the objective of this video. Now, a little bit more extension here. Okay, so remember we talked about your textbook taught you how to know the horizontal asymptote by looking at the leading power. So let's consider a sample question which is like this. Let's say we have a function which is like x squared minus 1 over x cubed. Okay, easy enough. And we want to find the horizontal asymptote of this function. So we will say, all right, so let's go ahead and do the limit as x approaches to infinity of x squared minus 1 over x cubed. Then you think about, okay, so compare these two. This doesn't really matter, so scratch it out, and then you have x squared over x cubed. And then you can do a little bit of simplification. So what you have here is x approaches to infinity of 1 over x, and you go ahead and substitute infinity into the x. And what is it? It's 0. So that's why your textbook would tell you that. Well, I mean, in pre-cal, they would tell you that, oh, if the power of the denominator, okay, it's greater than the numerator, then your horizontal asymptote is 0. Well, that's the reason. Okay, that is really the reason why it's 0. And I always wonder why they don't teach you limit earlier. It's not really that hard. It's just need a little bit more imagination. But anyhow, I hope you get it right now, okay? And you can practice more problems with the horizontal asymptote. And I urge you to try this this method, just to think through it, check your answers, but make sure you use this method to show your understanding on paper so that your teacher would not suspect you of cheating or any kind of reason that you get the answer illegally or suspiciously. Okay? Hope you enjoy it.